Good morning, good afternoon, and good evening, everyone, depending on where you're joining us from around the world. I'm Asif Hasan, co-founder of Quantiphi, and it's an absolute pleasure to welcome you all to Quantiphi's AI Confluence 2024, our premier research event celebrating the convergence of minds, technology, and innovation in the world of AI. Over the last 11 years, Quantiphi has established itself as an award-winning AI-first digital engineering company dedicated to solving transformational challenges at the heart of business. We excel at leveraging deep industry expertise, disciplined engineering, and cutting-edge AI research to solve some of the toughest and most complex business problems. In a world where AI is transforming industries at an unprecedented pace, staying ahead means not just adapting, but actively shaping the future. Over the past few months, our dedicated research team has been pushing the boundaries of what's possible in AI, and we're super excited to share some of those groundbreaking developments with you. Today, as we join together, there's no denying that we are in the middle of a technological revolution in AI, especially with generative AI. The recent rapid development in this space are reshaping our world in front of our very own eyes in ways both profound and subtle. We have an exciting lineup of topics covering a wide spectrum of AI applications, from agentic workflows to empower knowledge workers to navigate their professional lives more efficiently, to combining knowledge graphs and LLMs to improve the accuracy of code generation to increase developer productivity. One big area where we have done some pioneering research is in the area of life sciences. We will dive into topics like using generative AI to increase the speed and reduce the cost of drug discovery with applications like protein structure prediction and generative chemistry. We will also cover humane applications of AI to reduce the reliance on animal testing. Additionally, we will cover applications of AI to monitor the safety of in-market therapies, also known as pharmacovigilance. We believe in the power of AI, yet we are acutely aware of the potential harms that can occur if AI programs are not governed effectively. So we will wrap up our programming with an in-depth discussion of our research in responsible AI to ensure that our work is based on ethically sound principles and is designed with fairness, transparency, and privacy in mind, and has robust governance mechanisms to monitor and manage any potential risks. Let me now give you a glimpse into each one of these topics in a little bit more detail. First, agentic workflows for knowledge worker productivity. The current Gen AI revolution is not just about technology and hardware innovations, it's also about reimagining human potential. As AI takes on more routine tasks, we are challenged to redefine our roles to explore new frontiers of human creativity and problem solving while heavily accelerating the current methodologies. Recent studies from academic and industry forums have shown significant productivity gains across a wide range of tasks and roles with the use of large language models. Augmented with LLMs, we are seeing developers code almost twice as fast as they used to be able to do. We've seen consultants work 25% faster, and we've seen over 40% improvement in the overall quality of work. And over 70% of the test groups have reported increased productivity and time savings. As organizations adapt to this AI-driven reality and paradigm shift, focusing on knowledge worker productivity through large language models is not just timely, but also essential for maintaining competitiveness and driving economic success. And agentic workflows take all of this to the next level, where they accelerate not just the regular day-to-day tasks, but also more complex and nuanced business problem solving. We will see in our sessions how to build stateful agentic applications and how these agentic workflows help in accelerating and redefining the landscape of knowledge worker productivity. Second, combining LLMs and knowledge graphs for code generation and structured data querying. While LLMs have revolutionized our ability to process and generate unstructured data, recent research has opened some new frontiers in structured data analysis as well. In this segment, we will explore how we can augment LLM capabilities in structured data querying, or SDQ, by combining additionally and coupling it with intuitive and expressive power of knowledge graphs. This synergy between knowledge graphs and LLMs presents a game-changing approach to data analysis and contextual code generation. We'll examine how this combination enhances structured data querying by bridging the gap between natural language queries and complex database structures, making data more accessible to non-technical users. Third, let's come to intelligent document processing. While generating text and code are two major capabilities focused on LLMs, document processing remains a critical focus area, as they are often a significant source of information and knowledge in every business. The variety of document types businesses deal with is vast, ranging from invoices to contracts to forms and reports. According to the Association for Intelligent Information Management, about 80% of the surveyed organizations consider document processing as essential to their business operations and expect information management to become a more and more important domain of their work over the next couple of years. The projected global intelligent data processing market size is expected to be worth around $17.8 billion by 2032, growing at a cumulative annual growth rate of almost 29% for the next decade. Traditional approaches to document processing have long been the backbone of business operations. However, the recent developments in multimodal AI research are revolutionizing this document processing capability, allowing for more sophisticated analysis to not just text, but also to images, layouts, tables, figures, charts, plots, and even handwriting within these documents. Our intelligent document processing research focuses on intuitive ways to combine traditional methods with cutting-edge generative AI approaches to create a more robust, efficient, and accurate intelligent document processing solution. Next, let's move into tomorrow's programming, which is largely focused on AI in life sciences. First, we'll cover clinical document management and pharmacovigilance. Channeling our intelligent document capabilities towards healthcare and life sciences caters to several use cases like clinical document management and pharmacovigilance. Clinical trial processes typically run across multiple phases, resulting in thousands of documents being generated as a part of this process. This makes managing clinical documents absolutely critical, which generally includes collection, processing, storage, archival, and destruction of clinical trial records. Traditionally, these documents can vary vastly with respect to format, template, and processed manually, leading to increased costs and time durations. In our session on clinical document management, we'll see how recent advancements in multimodal AI and intelligent document processing capabilities help us accelerate this process. On the other hand, there is a growing importance of AI in drug safety monitoring within the pharmacovigilance industry. In our session on generative AI for pharmacovigilance, we'll explore how LLMs are helping pharmacovigilance from various sources such as clinical trial reports, scientific literature, and patent records, etc. By accelerating the applications like automated document analysis, drug safety and adverse event detection, causality assessment, and more. Second, we will cover generative AI in drug discovery. This moves us to a whole different frontier of understanding language of proteins and molecules. Historically, bringing a single drug to market typically takes over a decade and costs several $billion. Generative AI is changing this paradigm by accelerating every stage of the drug discovery process, from identifying targets to optimizing drug candidates. As we explore AI-driven drug discovery today, it's important to remember that we're not just discussing a few technological advancements, but the potential to save countless lives and push the boundaries of what's possible in human health. Specifically, we will dive into two key topics that are interrelated with each other. First, we will cover the generative chemistry framework. Our research teams have collaborated to build an end-to-end generative chemistry framework to generate optimized drug-like compounds by deriving insights from expert systems and docking studies. We will take a look at how leveraging open source and proprietary models in conjunction with legacy docking and molecular dynamic simulation approaches can help scale up every stage of drug discovery and dramatically reduce the time and cost constraints. We will also look at a practical approach for drug design via applications like de novo drug generation, scaffold morphing, and constraint property optimization. Second, enhancing protein structure prediction with molecular dynamics. In this session, we'll explore how cutting-edge computational tools are transforming our understanding of protein structures and dynamics and accelerating the path to novel therapeutics. Imagine predicting protein structures with unprecedented accuracy, visualizing their movements in real time, and identifying critical interaction sites for drug design, all at a fraction of the time and cost of traditional methods. Today, this is made possible by integrating tools like AlphaFold, ESMFold, physics-based molecular dynamics simulations, and automated docking pipelines. We'll look into practical applications of how these pipelines improve the efficiency and efficacy of drug discovery processes and how they can be tailored for other protein engineering and enzyme design tasks. Third, and this one is near and dear to my heart, digital animal replacement technology for animal-free testing. Following the identification of promising drug candidates, the next phase of the trial entails in vitro studies with historical reliance on animal testing. Each year, unfortunately, more than 100 million animals are sacrificed for toxicology studies of drugs, food, and cosmetics. However, there is a remarkable shift in the process in the form of digital animal replacement technology, driven by a growing emphasis on ethical research practices and innovative solutions. With the FDA passing the Modernization Act 2.0 in December 2022 and the European Parliament adopting a resolution to phase out animal testing, the need for the shift is more urgent than ever. Our solution, DART, for animal-free testing uses human stem cells, a digital workstation, and AI to predict drug safety based on stem cell drug interactions. In our DART session tomorrow, we'll explain how leveraging advanced machine learning and computer vision algorithms, data analytics, and well-developed wet lab infrastructure is forging a path towards more humane and ethical research practices while advancing the drug discovery process. Fourth, and perhaps the most important topic, is going to be responsible AI. As with reducing animal reliance in drug testing, ethical research practices and responsible AI principles is something we strongly abide by at Quantiphi. As they say, with great power comes great responsibility. All of the technologies being discussed in this event are transformational in nature, requiring us to not only focus on its benefits, but also grapple with crucial questions about ethics, privacy, and the very nature of human-machine interaction. In our responsible AI session, we will explore what responsible AI is, what our organizational responsible and ethical principles are, and how one can start using and integrating responsible AI into their organizations. Let me close by summarizing what you should expect to hear in the next 2 days. On day one, we'll mostly focus on large language models and augmenting their capabilities via agentic workflows and knowledge graphs. At the end of day one, we'll also have an esteemed panel, including some of the industry experts and experts from academia sharing their thoughts on agentic workflows and the future of AI with agentic workflows. On day two, we'll focus more on research efforts in life sciences. As we bring this keynote to a close, I encourage you to engage deeply with the content, participate in discussions, and take an active part in shaping the future of AI innovation. I hope you will take away something helpful and useful from the Qonfluence 2024 event, and that it inspires and challenges you to take some concrete steps towards embracing this research-driven future, be it initiating a brainstorming session, or signing up for a course, or revisiting a challenging problem with these new developments and capabilities in mind. Thank you again for joining us and for being a part of Qonfluence 2024. Your participation is vital as we push the boundaries of AI research and unlock new possibilities together. I look forward to the discoveries we'll make and the knowledge we'll share in this journey to transform our future and improve lives with AI. Thank you.